So another question, an experiment is carried out to determine the value of N, the formula of hydrated, uh, like how, zinc sulfate, how many water of crystallization are present in hydrated zinc sulfate that we want to identify. So the following steps were carried out. First, we weigh the empty crucible, then add 2 spatula of hydrated zinc sulfate, then we reweigh the crucible, and then we heat the crucible and hydrated zinc sulfate to remove the water of crystallization and allow the crucible to cool down, and we measure the weight again, mass again. Draw a label diagram operators setup for step 3. Step 3, we want to heat a crucible. So what should be the apparatus? So apparatus which we should draw will have this stand is there, and we place a crucible, and inside this we'll have a solid, and there should be a heat source, a source. So it should be all level. This is a crucible. This one, the hydrated zinc sulfate is there, and here the stand, tripod stand with a wire gauze or a net is there, and we have a heat source from the bottom. Then complete the table result. So we have to complete the mass of content after heating. So first, empty crucible is 13.6, crucible plus content 16.7, mass of crucible after heating 15 point, mass of content before. So that's why we subtract these two values, mass of content after. So we should subtract after heating and the original mass of the crucible. So 15.3 minus 13.26. This is 2.04. And mass of the water loss, so we subtract these two values, so it is 1.41. That's how we got. And how we get this mass of content after, because empty crucible is 13 and mass of crucible after is 15.6, so we subtract these two, we'll get the mass of the content in the flask. Calculate the amount in moles for anhydrous zinc sulfate left after the heating. So moles equal mass in gram divided by molar mass. So mass in gram is 2.04, and the molar mass, because we want to find the moles of anhydrous zinc sulfate, so that 2.04 which we work out is the mass of anhydrous zinc sulfate divided by molar mass of zinc sulfate. Using a periodic table, we'll work out the molar mass. So 2.04 divided by the molar mass of zinc sulfate, which is 161. So we'll get 0.0126 moles. So these are the moles of zinc sulfate. Then moles of water, how to work out? A mass of water was 1.41, molar mass is 18. So 1.41 divided by 18, we'll get the number of the moles of water, that is 0.078. Then we'll just take a simplest ratio because we want to find the value of N. So we have to take a simplest ratio between these two moles. So this was the moles for zinc sulfate, anhydrous zinc sulfate, 0.0126, and water H2O is 0.078. We'll divide by the smallest value, 0.012. We'll get the ratio between them, 1:2. So 0.078 divided by 0.012, so it is about 6.1. So 6 or 6.2, so it is about 6 because whole number should be there. So 1:6. So the formula here, it is ZnSO4 plus dot 6H2O. 6 water molecules are there and 1 molecule of zinc sulfate. So anhydrous, using a mass of anhydrous zinc sulfate, we got moles of anhydrous zinc sulfate using the mass of water, like the difference between hydrated and anhydrous zinc sulfate, we got the mass of water. Then using a ratio, we got the moles for water, and at the last we took the mole ratio. Then the data booklet give the hydrated zinc sulfate is 7. We are not getting 7, we are getting 6. Two possible errors that might occur in the experiment. Some of this hydrated zinc sulfate was lost from the crucible. Effect on the mass, if hydrated zinc sulfate is lost, then effect on the mass of water lost, that will be more, because if zinc sulfate will go out from the crucible, when we measure the mass before and after, so there will be a greater decrease in mass. Like original mass is not changing, but the final mass will be smaller value. So the difference in the mass will be more. So effect on the mass of loss of water, that will be more, or it will increase. And as a result, if mass of water increase, the moles of water will also increase. So here increase and moles of water, because the mass is more, the moles will come out more as well. Then the crucible is not heated long enough. So if the crucible is not heated long enough, it will not lose water of crystallization. So M2 will be higher. If M2 will be higher, the difference in the mass will be smaller. If difference in the mass will be, like, we are not heating it to make sure all of the water of crystallization lost. Example, these black spots are representing the water of crystallization. So when we supply heat energy, the water of crystallization is lost. But because we are not heating for long, so maybe not all of the water crystallization is lost, some is still left. So as the result, the decrease in mass compared to original, it will be smaller decrease in the mass, and if the change in mass is smaller, the value of the moles for water will come out small. So water of crystallization, that will decrease, and the calculated value of n will also decrease.